Welcome to this video assessment. The topic of this assessment is functions. Before we get into the syntax and how to use functions, first let's talk about why we would want to use functions. And I'll give you 3 reasons. The first reason is that functions break your code up into smaller, more organized bits, which make it easier for your eyes to consume the code from the screen. Okay, so far our programs have been pretty basic, but as we write more advanced programs, we're going to have an almost overwhelming amount of code. So being able to use functions to break that up into smaller organized bits is very useful. Another reason functions are very useful is that they're able to call or execute multiple lines of code at one time. Now, technically, the program will execute each statement in the body of the function one at a time, but for us as programmers, when we call the function, we won't have to write those statements each time. If we call it multiple times, then we won't have to rewrite the body each time. And to go along with that, the third reason, very similar, is its reusability, not just on the same object, but being able to use it on different objects. Okay, so we won't have to create a new function for a new object, and that will actually save us a lot of time. The only catch is the objects you're calling the function on need to match the function, so to speak. Okay, now that we've gone over why to use functions, let's go over the syntax and how to use functions. And to do that, we're going to make an example function. And to make it easy, we're going to just make a function that will divide two numbers. Okay, so there's 3 parts to a function. You have the function declaration, the function definition, and the call of the function. Okay, so the first part is the function declaration. And okay, there it is, our function declaration. Okay, I went ahead and cut out the parts of me just typing it up. Okay, so the first part is the return type of the function. The second part is the name of the function, which can be anything you want. And the last part of the function is the list of arguments, including the data type of each argument, and they're separated by a comma. Now, the reason I have the arguments defined as a float and an int is because the numbers I'm planning on dividing, the first one is going to be a decimal, and the second one is going to be an integer. And now the reason for declaring your function up here is similar to including a header file. The main function needs to know what's going on before it reaches that point. Okay, so now that we have the declaration done, the next part is the definition. Alright, so here we have our function definition now. The first line of the definition is nearly identical to the declaration. The only difference now is instead of having this semicolon, we now have the squiggly brackets, which is going to enclose the body of our function. Alright, so in the body of our function, we have a float type variable called result, and that is equal to num1 divided by num2. Then we're going to print the result, and the last part we're going to return the result. Alright, like we said, this was our return type right here. We're dividing a float, num1, by an integer, num2, and that's going to give us a float back. So that's why we have float as our return type. Now that we have defined the function, it knows exactly what we want it to do, the last thing we need to do is call the function. Well, we also need some variables holding numbers to call the function on. Okay, there we have our variables. We've declared 2 variables, one float, one integer, and we initialized them to 2.5 and 1 respectively. And now we just need to call the function on these 2 variables that we just created. Okay, here is our function call right here. Notice it's a little bit different than defining it and declaring it. Okay, so when you're calling the function, you only need to write the function name and the arguments that you're passing into the function. Notice that these arguments do not match the names of the arguments that we have in the declaration and definition. The reason for that is It's because we are passing in these arguments here. We want to divide well, that was weird. I don't know exactly how I did that. But anyways, we're passing in these arguments. So numero uno and numero dos, we're passing them in. It's going to go here. Numero uno is going to take the spot of num1. We're going to have numero uno divided by numero dos is going to take the spot of num2. So numero uno divided by numero dos. And that's going to give us our result. Okay, so now I'm going to run this program just to show you that we will get 2.5 divided by 1 is equal to 2.5. And there you go, result is equal to 2.5. Okay, one other thing I want to say too is that if you define a variable inside a function, then the variable is local to that function. What that means, if you define another variable with the same name, same type outside of the function and set it equal to something else, the function itself is not going to change the value of that variable. Alright, and now to show you guys that, I have introduced another variable that's got the same data type, same name, but we've set it equal to 10. Okay, so you can see that the result that was declared within the function is still equal to 2.5, and the result that was declared outside of the function is still equal to 10. Okay, now I know I already said one last thing, but truly one more last thing. This was the program from the loops video. Basically just sorts an array into ascending order. Alright, but now the only difference is I've made the bubble sort portion of the program into a function. Alright, here's the declaration down here. Okay, so I'm just going to run this. There's only one array in there right now. Okay, so you can see it was 654, now it's 456. And to show you that you can use it on multiple objects without having to redefine the function, I'm just going to uncomment out this other array that I made. I'm going to fill it with random integers between 1 and 10, and then I'm just going to print it out. Alright, so you can see here this was the second array, 322, now it's 223. Alright, and that's the power of functions. Thanks for watching this video.